I'm Nancy Gohring. I'm a senior analyst at 451 Research, where I follow application and infrastructure performance. Observability has become a pretty hot topic these days in the world of monitoring. So what is observability? I like to think of it in terms of making your systems observable. And sometimes it really helps to think of observability in terms of how it's different from more traditional monitoring. So in traditional monitoring, you very often have a bunch of dashboards that you set up in advance that help you understand when a performance problem is happening. But in modern cloud-native type environments where you might have microservices and containers, maybe you're running Kubernetes, your system is much more complex and dynamic. And you very often can't predict in advance the kind of problems that might occur. So you want to make your application infrastructure environment observable so that you can flexibly dig into what's going on so that you can figure out the cause of a problem and fix it really quickly. Very often these problems are unique. You can't pre-configure a dashboard because you haven't predicted that it might happen. So that's, I think, really key to achieving observability. It's collecting the right data set and making sure that you can flexibly dig into that data to discover what's happening. So if you want to transition your monitoring practice into an observability practice, there's several things that you should think about doing, and I'll touch on 4 of them. So one is you want to make sure that you're collecting the right types of data and that you're able to do so at scale. So very often when people talk about observability, they think about metrics, logs, distributed traces, maybe events. But it's become increasingly clear that these different types of data have different kinds of value when you're trying to figure out what's going on when you have a performance problem. So you're going to want to collect a variety of types of data. And because your environment is probably much more complex and dynamic than a traditional environment, you're going to need to collect a much larger volume of that data. There's more pieces, there's more components of your application. They generate more operations data. So you need to ensure that you have the scale on the back end to collect that larger volume of data. And on a related note, because you have these different kinds of data and at a very high scale, you're probably going to need to employ advanced analytics, which might include machine learning and/or artificial intelligence. You've got this huge volume of data. How do you sort through it? How do you figure out what's important? How do you get intelligence out of that data? You're probably going to need some help from some of these advanced analytics types of tools. You also are going to want to make sure that you have good context about what's happening. And this is particularly important if your application is built using microservices. So you need to understand how neighboring or dependent services might have an impact on the performance of the service that you're responsible for. But context is important actually from a number of different perspectives. Another is in terms of the perspective of your end user. So sometimes performance problems are happening in a cloud-native environment that actually don't impact the end user. And if you have a bunch of incidents happening, it's really important to understand the context of the incident so that you can prioritize your reaction to them. You're probably going to want to fix the customer impacting incidents first. And then finally, I would just encourage you to think about some of the open source software that's gaining popularity in the world of observability and monitoring. So for instance, Prometheus has really grown in popularity recently as people are adopting Kubernetes. Also OpenTelemetry, there's some good enthusiasm there, and it can be particularly helpful when you're deploying distributed tracing. So these are some of the things that you should think about if you're trying to evolve from a monitoring practice to an observability practice. There are a lot of challenges that you can address and solve when you shift to a modern observability practice. And one of the most basic, but also very impactful, is quelling alert storms. So I talk to a lot of organizations that talk about drowning in alerts, hundreds or thousands of alerts that come in at once, and it's very difficult to figure out which alert is relevant. And a lot of modern observability tools will group alerts by incident. So rather than having to sort through hundreds or thousands of alerts to figure out what's important, you know that they're all related to a single incident. And sort of on a similar note, another challenge that can be solved with observability tools is that a lot of these tools also do some root cause analysis. So, once your tool has grouped all those alerts together, it may be able to guide you to the one that points to the root cause of a problem so that you can more quickly fix it. Some of that is based on topology insight. Some of it's based on insight into change that's gone on in the environment. But these tools are getting increasingly smart at helping point to the root cause so that you can more quickly solve problems. In addition, these tools, observability tools, can really help teams prioritize their work. So in order to do that, you need to have an understanding of how incidents impact users and the business. A lot of teams I talk to don't have that kind of insight. They don't know how to prioritize which incident they should focus on, or they do it just based on gut instinct. But a lot of these tools make it much easier to understand the impact that incidents are having on customers and or the business, and that can really help teams prioritize which incidents they should work on first. A couple more things I'll mention, and these are sort of early days, but I think interesting. So I've heard a lot more interest from organizations in trying to apply their observability tools and practices earlier in the development cycle. So even in pre-production, in ways that can help drive more quality code. So for instance, these tools can be used for release validation. So to make sure that code has actually met requirements before it goes to production. I'm also hearing a lot more organizations tagging new code pushes and sometimes even employing some kind of automation to make it very easy to roll back a code push if it becomes apparent that it's causing a performance problem. And sort of on a similar topic, I think one thing that's really important about implementing observability tools and practices is the potential for auto remediation down the road. So auto remediation has been, a topic for many years. People are very interested in it, but also cautious about it. But something you need in order to auto remediate is an accurate indication of the root cause of a problem. I mean, you can't automatically fix something if you don't know what to fix. And so I think that's a really important part about observability, is that you're putting the tools and the practices in place that can potentially accurately pinpoint the cause of a problem. And down the road, that might let you implement automation techniques so that you can automatically fix problems once they occur. So I think these are some of the really important and notable challenges that you can solve, or that you might be able to solve by implementing a modern observability practice.